Guys, welcome back to our YouTube channel. Today we want to find the value of x, given that we have 7 to the power of x equals 3 to the power of x plus 2. So guys, let's have it to be solution. We have 7 to the power of x equals 3 to the power of x plus 2. But let us recall from law of indices, when you have a to the power of m plus n, this equals when you have a to the power of m, then multiply by a to the power of n. So by applying it here, then we are going to have this as 7 to the power of s equals 3 to the power of x, then multiply by 3 to the power of 2. Now let us do something reasonable by dividing through by 3 to the power of s. Divide this one by 3 to the power of s. This will cancel this. So we have here to be 7 to the power of s divided by 3 to the power of x equals 3 to the power of 2. But mind you that when you have a to the power of m divided by b to the power of m, this always will give you as when you have a divided by b, then in bracket all to the power of m. So by applying it here, because it's applicable, they have the same power. You can have this as 7 divided by 3 all to the power of s equals 3 to the power of 2. Again, let us introduce something reasonable. When you have something of this, we want to apply log. By applying log to both sides, so we have here to be log of 7 divided by 3 all to the power of s equals log 3 to the power of 2. And mind you again that when you have log of a to the power of m, this equals as when you have m log a. So by applying it here and here, we are going to have this as s, then multiply by log 7 divided by 3 equals, this will be 2 log 3. So obviously, from here to get value of s, we can divide through by this. When we divide through by log 7 divided by 3, this is also log 7 divided by 3. This we cancel this. Then we have our s to be equals 2 log 3 divided by log 7 divided by 3. Now, let us recall that when you have log a divided by b equals when you have log a minus log b. So by applying this one here, we have our s to be equals 2 log 3 divided by, this one will be log 7 minus log 3. So now from here, we have s to be equals 2 multiplied by log 3. When you press log 3, we have log 3 to be equals 0.4771, then divided by log 7 is equals 0.8451, then minus log 3 again 0.4771. So now from here, this equals 2 multiplied by this, we have 0.9542 divided by this minus this, we have it to be 0.3679. So when you divide this by this one, we have our x to be equals 2.5936, which approximately equal to 2.6. So this is approximately equal to this. Now let us check if the value we get will satisfy the problem given to us. So we have 7 to the power of s equals 3 to the power of s plus 2. Then when s equals 2.6 approximately, we have here to be 7 to the power of 2.6. Then is it going to be equals when you have 3 to the power of 2.6 plus 2. Then we have here to be 7 to the power of 2.6. Then is it going to give us, when you have 3 to the power of 2.6 plus 4, 2 plus 2 will be 4.6. And so therefore from here, we have, when you press 7.6, we have it to be 157.5, which approximately equals to, when you press this one again, we have 157.5. So this is true for the value of x equals 2.6. Now, here are the steps. Let me re-explain from here. So we have 7 to the power of s equals 3 to the power of s plus 2. Now, we apply law of indices. That says when you have a to the power of m plus n equals a to the power of m dot a to the power of n. And so by applying it at this right hand side here, our a equals 3, then our m equals x, our n equals 2. So we have here to be 7 to the power of x equals 3 to the power of s dot 3 to the power of 2. By applying this one here, that's why we have this. We want to divide the 2 by 3 to the power of x to separate x from just ordinary constant. That's why we divide through by this. And by dividing through, this cancel this, we have 3 to the power of 2. But mind you that this is power s, this is power x. According to law of indices, when you have a to the power of m, b to the power of m equals a divided by b in bracket all to the power of m. Now, we got this equals 3 to the power of 2. Now, the only way to get the value of x or to make sure that we have x to be in base is by introducing logarithm. The moment when you introduce logarithm, this one will come here. Should you get now? That's why we introduce logarithm. This one come here. We have this, and we apply the theorem of logarithm or the rules. This one gives us this. And after that, we have 2 log 3, and we have x log of 7 divided by 3. We divide through by this in order to get the value of x. That's why we have 2 log 3 divided by log 7 over 3. But in logarithm, division normally changes to minus. When you have log of a divided by b equals log a minus log b. And we have this to be equals this. So the moment when you substitute everything, we get this, then we multiply by this, we get this, we subtract this, we get this, and that's why we got this. Bye bye.